All right. All right. Hello, and welcome to today's Plumbers of Data Science episode. Um, this is part 4 of the data engineering course that is completely free and that you can follow here on this channel. And today we are going to talk a bit about Lambda architecture and more into streaming and batch processing, because I got a few questions about how is that work, and people are people really using that, and what's a use case of stream and batch processing to doing that together. And I think that's quite obvious, and we should go over this. Also, I have some other things like AI transformation of companies. There is a playbook that is quite interesting. And what we're going to talk about is a data scientist versus data engineer. We need to clarify this for this training, because still people don't understand the difference. And I want to mention here a blog post I have seen, and that is very, very interesting, and I suggest people should read. So I want to get this info out here. Okay, guys. All right. How are you? New week, Monday. I hope you have or had a great start into this week. Yeah, great. That's great to hear, Nick. Awesome. Yeah, I'm on parental leave for the next 4 weeks, so I have a bit more time or less, depends on how you want to look at this. Yeah, this evening is going to be interesting, also for me. I didn't have that much time to prepare as I would have liked. Yeah, but let's get into the action here, and let's see what this brings. I also just scrolling here. As always, if you're not subscribed to the channel, subscribe to the channel to get the updates of this training, and hit the like button on this video so we let the algorithms know that they should share this video. Yeah, I'm also every time the coolest thing of this is not what I'm talking about here. Let's say a training. The coolest thing here for me is the Q&As. Last week we had on Friday we had a great Q&A about this, that people said all this big data or data science processing is stupid, and with their Postgres database that is enough. And then we figured out that then all this stuff maybe not the right thing for them. So I like these conversations that we have here, and yeah, this is always great. Okay, before we get into the hardcore stuff, some interesting stuff I found on LinkedIn. Let me just pull this up here. Here's a problem with the coding and AI, and here's basically the problem that we see. The noobs, they want to take the first step from hello world directly to AI and ML, and I think this is this fits the whole situation right now very, very good. Yeah, I'm. By the way, I'm going to upload these things on my podcast. I have downloaded all the episodes, and I'm going to make a podcast update so people can listen to it. So if you're listening to the podcast when I have uploaded it, it's basically a staircase, and some kid is standing with 1 foot on the hello world, and then 1, 2, 3, 4, 5, 6, 7 steps ahead is the next foot, and he is on AI and ML. So this is, yeah. So object-oriented programming, data structures, algorithms, all that in between. People want to skip all that because AI. They need to do AI and ML, and yeah. I don't even think he's standing on Hello World here. This is just one thing I found very interesting, and this is because people are telling you that it's super easy, and just start with it, and then you do AI. This also leads me to something that I have seen, and this article I really liked, that I have seen on shared on LinkedIn, is why data scientist is not a data engineer. Hi, Dragonfly. Yes, I have arrived. Welcome. Why data scientist is not a data engineer. This is this is a quite a long article, but I really like it, because that shows basically why is it, let's just go over why does that even matter. And here they tell a short story that they have some there's a company, and they have venture capital money, and want to make a ton of reinvestment, a return on investment. They want to have a great return on invest, and so what they do is they hire data scientists. And so they say, okay, Bob that's data science first day, and then the manager basically comes and says everything that they have in mind, and then the data scientist says, that's great, where are these data pipelines, and where is your Spark cluster? And Alice responds, that's what we're expecting you to do. We hired you to do data science. And this is the problem right now. I don't know how to do any of that. And there is this funny oversimplistic caption is quite telling. Oversimplistic Venn diagram. Data scientist, data engineer. There is a common amount. And in the middle here, this is big data, and these things hurt. Then they go over some stuff. Why does the management doesn't understand the data scientists aren't data engineers, and why do some data scientists think they're data engineers? And the first thing they go over why the first question, why does the management doesn't understand it? And what they are basically saying here, and I can tell you this from my own experience, data engineers, or the engineering behind, doesn't get a lot of credit. So the most credit is given to the data scientists, to the to the AI engineers or AI scientists, and in presentations, or they mostly don't talk about the engineering. They talk about the algorithms and the shiny stuff they have created. And this is one of the things that basically the management doesn't see the engineering, because the data scientists never really talk about the engineering. They also say there is a bit of a move, but this is a bit of a problem here. I like this this picture here. Even the Italians knew the importance of data engineers in the 1400s. So the engineer is carrying the data scientist from a data engineer's perspective. This is quite funny. Yeah, and then what they are saying that now there are conferences about data engineering and people are talking about it, but you have to keep basically all both teams, the engineering and the scientists. You have to give them credit, although if you don't do that, they are going to leave. Yeah, so basically data scientists aren't data engineers. This is about the second question. Why do they think they're data engineers? And this is blah blah. I'm wondering if the intelligence causes a higher IQ. Dunning-Kruger effect. Do you know the Dunning-Kruger effect? Have you ever heard of this, guys? Have you heard about the Dunning-Kruger effect? Because this is very very interesting, and I see this. I see this a lot of times. No, this is a study. These guys done. This is a long time ago, so it's not a recent study. But what they have found is, if you are relatively unskilled in a task, it doesn't matter what it is. So let's say you want to repair a engine from a car, and if you look at it and you're a complete noob, you don't have an idea about all this, you're no specialist, you're most likely to overestimate your skills and basically think the stuff is easier than it is. And the other way around, if you're the specialist, you always think, or you're putting yourself on a lower stand. So you're more how do you say this? You're more aware of yourself. You're more skeptical, or you're yeah. I'm missing the word here. So the essence here is the thing that mostly if you're unskilled, it's way easier, and more people are overestimating their abilities. So Dunning-Kruger, you can Google this. Yeah, we can just Google this quickly. Just let me just quickly. This is really. Of course, there are some critics and so on. Let me just put this here. Cognitive bias. I'm going to put let's not go over all this. I'm going to put the link in the description after the video. But there are articles about it, and it's really really funny. So basically, what a lot of scientists, they think they are actually here in the engineering ability, low to high, and most of them are somewhere here, but most of them think they are here on the right side. So what they have found, and when they are doing a assessment, basically they have found out that the data scientists always think they're doing more, or they are more skilled in data engineering. The other way around also, as you can see, there is some common, or those both are, though the skills for engineers who are doing AI, and the other way around, they are overlapping. So there are also data engineers who are doing AI or doing machine learning, and they also think they're better than they are. But it's not bad. I mean, what they say, Yeah, okay. So they have said basically what moderately easy data pipelines can be done by a data scientist, but when stuff gets more complicated, then they're out of their depth, that they're not they're not capable anymore. How they define here moderately complicated data pipelines, I would say. This is all very simple. So an example of a moderate is a bare minimum of processing text files stored in HDFS S3 with Spark. This is a very, very simple one, I would say. And wasn't there an example for a more example of a moderately complicated data pipeline is to start optimizing your storage with a correctly used NoSQL database that use binary format like ever. I would say if you're the example for like with S3 or getting data from Hadoop and processing it, that's a very, very simple pipeline. But a more where the data scientist will get out of or will not be capable or will have problems is when you have to design a pipeline like we've seen in the last stream with multiple steps. You have to use multiple tools and also what we're going to build over time in this on these streams and for this course. Data engineering is not equal to Spark. Yeah, so many people think Spark is the tool to actually use everywhere. That's not. It's just very, very popular, but you can have you can use a wide variety of tools. Also with the coding, you can write they say, and that is true, from Stack Overflow here. I can get all the code I need from Stack Overflow or Edit. Of course, let me just make this a bit bigger. Of course, that is absolutely true. But they argue, and I would argue as well. This code you get from Stack Overflow is the bare minimum. This is you have to do a lot of work to make this production ready. That's because those are mostly templates or simple examples. Also, the what's the longest their code has been in production. Yeah, so and also how hard is it to write the code? So is it just a 20 line program? Or is it 1,000 lines of code program? So there are there are many differences here, and designing systems. It gets very, very complicated. Yeah. Okay, that's it. Yeah. Code quality also. Yeah. Okay, so the thing here, you can, as always, I'm going to put the links in the description. As always, a mixture is important, and it's totally okay if you have data scientists who are doing engineering work, but you need to know at some point you need a dedicated data engineer. What I'm always arguing is, from another point of view, if you have a data scientist and this guy is here to do, you're paying a data scientist to do analytics, to do machine learning, to create AI or whatever you want to call it. You get a data scientist to analyze some data, make some output, to to create some knowledge. And so why would you use a data scientist to do a data engineer's work who is completely different, and let him spend his time on a task that is not his core competence, that is not his core purpose? It's way better if you have a dedicated data engineer who is building the background systems up, who is building the processing pipelines, who is organizing the data and how it gets stored and formatted and so on. So the data scientist can concentrate on his work. So why would you do that and do everything with a data scientist? That makes absolutely no sense. And yeah, it's also frustrating for, I guess, for data scientists. Oops. Okay. A few comments. Somehow it was wrongly here. It wasn't live. It was top comments first. Chloe says, I just taught myself Scala over the weekend. Okay. The production part is the real deal. This is what I need to know, says Dragonfly. Yeah, Chloe. I also did the jump from Java to Scala some time ago, and what I have found, basically the basics are very similar or very easy, but this can get very, very tricky and fun, in my opinion. Also, I don't know, have you used any book with that, or what book have you used to basically learn Scala? Nick says data engineer has to provide data and infrastructure, so data science and other analysis. That's the simplest explanation. Yeah, that is it. And articles like this one that we've just looked at is very does help people understand. There are some little drumsticks under my desk from my daughter. She played here today. Oh man. Chloe says I programmed in Python for a year and the array aspect is similar. Also there's Lambda aspects in Python. Yeah. Yeah, I mean Scala is fun. It's good. Yeah, guys, ISPs is always fun. People always have problems. I recently had problems here with the streaming. That I tried it and it didn't work, and then I needed to restart my router, and stuff like this is always fun. Yeah. Okay, let me just what did I do next here? Okay. Just something else that I have found, and I found this very, very interesting. People always say AI is the thing, and it's if you only look at the positives, so the basically the some call it the green path, that something functions as it should be, but you're not testing against it or doing some let's say adversary tests, then you have some problems. And here are some guys. They have built a machine learning program or an AI that is registering persons, and this guy gets detected very, very easily. And this other guy, he has a picture here of a few people, and when he has that in front of him, he's basically invisible to the system. So just this tells you the algorithms are not perfect. What you're going to see is in a few seconds. Now he's going to put it away, and boom, here he is again. So I found this very funny. When he puts it in front of him, it's so. In a few years, when we have the social credit system, or how is that called in China, and you see people running around with pictures in front of them, you know why. Okay. I just need to follow here a few. Okay, so let's move on. What I also found, and I've also found here, and I've talked about this with a few guys. I quite like this. It's from Landing AI. This is something that from Andrew Ng. This is how to basically get in or make your company a. I hate this AI company, because people always ask me who needs data engineers and who needs data scientists. People can figure out more or easier than data scientists, but who needs data engineers? And what they say here, they have a few steps, and the thing that they're doing. So if you have a company and basically a company that is here for a long time, it's not about startups, it's about older companies or companies that are in business for a long time, and they want to transform their company into a AI company. Oh man, I hate this word, but what can you do? So what they say is execute pilot projects to gain momentum and build an in-house AI team. And this is where people are, or where a lot of companies in the future are going to also need data engineers, because as we have seen, data scientists alone basically can bring you or can get you only so far. And in my opinion, this is where we're going to have a big need of data engineers. When companies are starting to execute the first pilot projects, and then they're doing more refined projects, and they're building an in-house team, and this team then needs the tooling, and it needs the platforms, and so on and so on. And this is I think this is a crucial part here, and it's a good strategy. You do pilot projects, then you set up a team, and then you provide a training to the management, so the management if they don't already understand why they are doing this, provide a training. Why is this important, and what value can you get for it? And then you're developing a strategy. What do you want to do with this AI team, or where do you want to go in the future? And then communicating it. But I think this is a quite a good approach, and quite an interesting approach. And yeah, this is where we are going to have a lot of data engineers when they deploy here better product, more users, more data. Better product, more users, more data. The old cycle, and this cycle cannot be done just with data scientists. You need engineers for that, and so this is where where we need data engineers. Yeah. Okay. Yeah. Check this out. It's called Landing AI, and they have AI Transformation Playbook. It's a PDF, or you can watch it online or read it online. It's either way. Yeah. Android is basically everywhere nowadays. Yeah. Okay. I already downloaded it. Now let's get into a bit more into the whole thing with Lambda Architecture, batch and stream processing, and yeah, guys, do you like this already, or have you already more questions about this? I'm seeing some confusion here about Lambda Architecture and Lambda functions. How Chloe, that Chloe mentioned regarding Scala. Yeah. Otherwise, we're going to continue. Have you guys already seen this AI transformation playbook? What do you think about this stuff? Or your current company, how is that? How is that going with the transformation? Because many companies, I guess, are going to struggle and are going to also going to struggle. Not only the execution is what they're going to struggle is getting the right people for that. Okay, I'm going to move on. Nick says, "Oh God, there is a lot of AI transformation stuff like this." Yeah, but I don't really like this. That everything is right now is called AI. It's if you hear AI, you're overestimating the stuff that is currently possible and what people are working on, because a lot of things you see is like from Tesla, autonomous driving and so on, but this is not the yeah, Caleb, of course, like all the other videos, I'm going to leave everything up. I'm deleting nothing here. What I want to do here is I want to evolve this thing here into a training, into a online course in the future, so people who don't want to spend the hundreds of hours that it takes to do this thing, to get a online course, and that we have a lot of fun in the meantime, and that I want to create basically a journal for me and for you to basically see how this channel and how these talks and these topics here evolved over time. This is why I will not delete stuff here. This is everything is open, and everything is going to stay here. Yeah, I'm right. How? Yeah. Okay. What I'm doing is basically the course or the documents for the course that is going to first land on my Patreon. There's already on my Patreon for the cookbook, and this is just to have a one place of storing data or information. Yeah, I'm not sure about the quantum computers. Um, yeah, I'm not that into quantum computing, so I can't comment on that. Okay, let's move into something that has sparked the topic of this video. Um, yeah, we're just 35 minutes in, and I get to the topic that is in the description of the video. But there was I have a on LinkedIn. I have set up a group that is called like this channel Plumbers of Data Science, for not only me to post stuff, for also you to post stuff that is that you find interesting for data engineers, and yeah, to basically make a collection of interesting stuff on LinkedIn. Because on LinkedIn, once stuff is gone from your timeline or from your feed, you're never going to find it. Okay, and so Divium, I'm sure I'm butchering the name here. Divium asked, "Hi, I was going through Lambda Architecture in this link. I have the following doubts." I'm not sure what that link was. Okay, he mentioned here the wiki page for Lambda Architecture, which, by the way, is horrible. And I have following doubts. What are the scenarios where real-time and batch processing needs to be done together? And so basically, let's do the next question. Let's just go over the three questions. So what are the scenarios? It says both batch and stream processing is in sync. How is this done? What happens to real-time data once it's processed? Does it go to batch processed results? So also, if anyone can elaborate more on how Lambda architecture helps in real world, especially listing the most used scenarios. There are multiple scenarios, and I quickly mentioned this in the last video, I think, and I have written about this or put this into the cookbook some time ago. The first thing that people need to understand is basically why would you do, or how does that work, or where's the difference here? So if you're just here, so the thing is, you need to understand with the batch processing is, what do you want to do with batch processing? With batch processing, you want to answer the big question, the questions where you need a lot of data for it, and you want to make an analysis over, for instance, over months, over years, over all the data you have, or a huge chunk of data you have. And what is going to happen is the data is going to get into storage at some point. This is how we've seen before with the moderately complicated data pipeline for a data engineer. Data is going to get stored somehow. Let's say it's stored in HDFS in files. And then what you want to do is you want to make a batch analysis either once a day or just once, because you want to have a one-time result. You take a huge chunk of that data and stored, and you process it, you analyze it. This can be Spark, this can be Flink, Storm, Heron, whatever. Heron is more streaming, but it doesn't matter. You take that huge chunk, you analyze it, and then you're creating, let's say, big insight from that, because you're having this a big amount of data that you're processing. That you can do that with batch processing. Then on the other side, if you want to do stream processing, why would you want to do stream processing? Because you want to get information very, very quickly. You want to have every second an a answer to a question or a result. Then what would have is you have your data that is coming in, like from an API or from a user interface. This is going to go into analytics. It's basically, it would flow like something like the API is going to post into Kafka, and then the analytics is reading every, like with Spark, in micro batches every 30 seconds, or if you have a real streaming solution, continuously, very, very quickly. Every message that is coming in is getting directly processed, and you're creating insight directly on the flowing, the raw data. And the idea is this quick insight then is getting stored somehow, just for instance in a user interface or an analytics storage, something that, for instance, your Google Analytics or Google Analytics for web pages. This is stuff that is flowing in when you're looking at the real time, a few accounts, and then it's getting stored in the front end database, and you can watch it. So this is okay. Let me just go on. So this is I read your comment, Nick, that this thing should be deleted and is retired. This is for me. This is still okay. Let's get to it. For me, this a way of processing data is still very, very, very valid, and it's very well defined, and a lot of people know it, and the tools are very optimized for that. You have a wide variety of tools. You can do this both in this way. So for me, this is the thing I have learned to like, and yeah, these hybrid solutions you're talking about, I don't know if you have a link or something, or some suggestions. We can look at it at this right now. This is for me the thing that I like. This you have the stream and the batch processing types, and a real world scenario. What you want, where this works together is you have this. Let's say you want to do, you are a data engineer, you have built the platform, and data scientists want to use the data on the platform. What they are going to do is they are going to generate models. They have their algorithms, and they generate models, and these models, once they are built and they are tested, they're going to be put in production. So new data is going to basically be evaluated or analyzed or sent to that models, and then processed, and you get results. So what the data scientist would do is he would do batch processing with a lot of data, and he would run the training for his algorithms and basically build up the model. They build up the machine learning function, and then he would do that with batch processing, and then in the quick way, in the quick result, for getting the quick results, he would deploy this into stream processing, so every new data point is getting in there and is getting analyzed right away, and the insight is going to be created. Like, let me just go back to the cookbook. Whoops, where is it? So in the first step here, in batch processing, the data scientists would right here and analytics. This can be everything. This could be a standalone Python project, Python code. This could be Spark, Flink, again, whatever. And he's going to take data from storage, for instance, in an ETL manner, and then he's going to analyze it and create his model, create his machine learning function, and then what he's going to do, he's going to deploy this for the stream processing. So data comes in, is getting applied to the model, and the model directly creates the insight, like we have seen with these guys with a picture, and that is basically recognizing or detecting people. Same thing. This is then the stream processing job or stream processing way, and yeah. So yeah, Nick, let's just quickly look into Kudu. Let's just say, didn't you post something on one of the videos I have? Which one was that? Because I have looked into this one slide share that you have posted. Let me just bring this up here, if I can find it, because I'm in the studio. So live streaming. Which was that? Do you still have the link, Nick? I can't find it. If I can't find it that quickly. Community. Damn it! I cannot show you to. This doesn't help me because this is on the other computer here. Okay, I think I already found it. What's that called? From Cloudera, Lambda Architecture. This is it. Moving beyond Lambda architectures with Apache Kudu. I think this is the one you were referring to, right? Great. Okay, let's quickly look into this. This is Lambda. Okay. Challenges. This is stuff we have already looked into. Spotify and Airbnb. I wasn't sure what they were saying here. Sorry for the squeaking. I need to oil this thing here. Today, everything that can be measured will be measured. Data testing. These are more blah blah slides here. Data is abundant and diverse. Determined, understand, change what happens. Determine what happened. Understand why it happened. Change what happens next, and make it happen consistently. Okay. Yeah. Okay. Why big data? We're going over this. We're not going over this. What is Lambda architecture? Okay. This is a simple thing here. You have some data, new data. This is going to get into a data lake, like HDFS, like I said before, and then you're going to do a computing on top of it in a Hadoop layer, and this data then gets into Impala, into like a database, and this is merged with then used by a data application. And I'm guessing this here, either this is a front end or something, but this could also be something like Tableau or on the serving layer here. So on the other side, on the stream processing side, you have new data that is coming in, and in a stream or a micro batch, and then you have some incremented views, like I said, with quick insights. Every 30 seconds, one data point, and this is also put into something, for instance, like HBase, and then ends for the serving, for the data application. Okay, batch layer manages master data set and immutable. Append only set of raw data. Okay. Pre-compute views. Yes, we've seen that. Traditionally, this has been in HDFS and produced with MapReduce. Very traditionally, yes. There's already been some shift to cloud-based object storage and processing in other frameworks like Spark. Yes, with Spark you can, for instance, use S3. Speed layer. Okay, this was the batch there. Okay. Speed layer and just streaming data, micro batching, Spark and Storm are traditionally used here. That's also true. In some cases, micro batches are directly ingested into NoSQL data stores like HBase. Yes, you can do that. How can you do that? Yeah, of course, from the speed layer. Yes. Data is periodically expunged. I'm guessing this means deleted. In many Lambda-like architectures, I've seen this layer is used to provide an active partition that provides a limited window of mutability. So this is a active partition, a quick thing. Yeah, we're Dragonfly. We're coming to Kudu here, and I think we can talk then with Nick about this more on these views. So Kappa Architecture then would be we've already talked about the Kappa Architecture in one of the previous streams. Would be then no batch layer, only streaming. What was this here? Batch stream. Why is this now again batch and real stream processing? Okay, I don't really understand this here, I have to admit. Okay, let's move on. I don't know. Okay, I guess this is more Kappa Architecture oriented here. Okay. Last time I just went quickly over this one. Lambda advantages and disadvantages. Okay, now it gets interesting. Advantages: marries diverse strengths of existing open source software into a unified architecture. This is absolutely true. You can, as I said before, you can use many tools to do this sort of stuff. And the scalability through the batch layer is very good because you can get a lot of machines to scale this stuff. But I think, why isn't the scalability for the Streamlink layer? Yeah, provides real-time performance via the speed layer. Okay, this is all what we've talked about. Disadvantages, complexity, many moving parts. Yes, it has some tools. Yes, that's true. What is restatement? Restatement. Act of stating something again or differently, especially more clearly or convincingly. Okay, so if you want to change stuff, then this is more complicated. Two code bases must be kept in sync. Yeah, but then again, you would not do the same stuff in batch processing as in streaming. But in the case of machine learning, yes, you would want to have the code bases for the algorithm creation or for the model creation, and then one for the apply. Proper failure handling is complex. I can definitely sign that. It's sometimes but I think this is generally a problem with distributed processing. Finding the problems. This is problematic. Lambda complexity must be kept in sync. Where is the other stuff here? Kudu as a lambda alternative. Okay, now we're getting there. Yes, I have seen this. So basically, HBase as a key value store has more is more real time oriented and fast online updates and data serving. Kudu is something that is coming also there, but it's not only real time. It's fills the gap. Modern analytic applications often require complex data flow, difficult integration work. Okay, to move data between HBase and HDFS. So it's something. Okay. HDFS is append only. Yes. Fast scans, analytics and processing of stored data. Yes. Okay. Fast changing, frequent update. So the Kudu is also good here. Is there more? I'm looking for an architecture thing here. Okay. Okay, this is a standard from Xiaomi, big data analytics. This is I'm guessing this thing here is based on the Lambda architecture. It looks like. So you have the data source, then something goes into HBase or into a file, so a sequence file. Then MapReduce is going to take either the files or the data from HBase and is doing some stuff for either serving the results directly or moving the data into HDFS with Parquet files, and then you have Impala where you can do the serving. The problem here, high data visibility latency. So it takes some time for the data from here to get to the serving layer. And you have to do some data conversions. Yes, you have the source data that needs to, in this case, needs to be stored into sequence files. These sequence files need to put in Parquet files, and then you have to do another formatting to get the results. This is true, and with HBase it's the same. Okay, then with Kudu. With Kudu, what you would do is okay, this is for back pressure handling. You do use the either you write directly to Kudu, or you can just write data into Kafka and then with Storm process it and write it into Kudu. Okay, so if you have problems because this thing is not cannot you have performance problems here, and you're getting back pressure, so data gets faster than you can store it. For instance, in some peaks, you can use this path. Okay, this makes sense. And then you can directly connect to Kudu from the serving layer. Okay, this is interesting. Or with Impala, then connect to Kudu and use for the serving layer. So basically, if you already have Impala usage here, or you're familiar with Impala, you can just use Kudu here. Okay, that's interesting. So low latency ETL pipeline, 10 seconds data latency, of course, because data is, if you directly ingest and can access it here, this then goes quickly. For apps that need to avoid direct back pressure or need ETL for record enrichment. Okay. Direct zero latency path. Okay, this is the low latency ETL pipeline. This is the one here on top. And direct zero latency path for apps that can tolerate back pressure and can use the NoSQL APIs. Yeah, this is always the case. If you can, if your data source can deliver you a constant stream of data and doesn't have high peaks at some points, or yeah, then you don't really need this ETL thing here on the top, the complication with Kafka and so on. For apps that can tolerate back pressure and can use, yes, I already read that, sorry. Apps that don't need ETL enrichment for storage retrieval. Okay. That's interesting. So what they just did is they switched out HDFS and MapReduce and HBase and the sequence file stuff, and they only kept Impala here. Okay, interesting. Oh, that's already everything. I thought they had another. Lambda has a real place in big data architectures. Optimize needed, but beware of the cost. Premature optimization. Yes, the cost is very high. Kudu is designed to be a simple solution for when you need a data store that's updatable and proves good enough performance for analytics and real-time workloads. Okay. Oof. Okay, I find this here interesting. This is a super interesting slide. Let's just check the let's just check the comments for a second, and then I would like to look into the APIs. Nick is advertising here. It says, but it says, yeah, it's a great thing, but I'm not working for Cloudera yet. Tess, never heard of Tess. We cannot watch any videos here. I'm reluctant to watch any videos with, especially with sound, because I don't want to get any copy strikes on this channel. So, yeah. Okay, let's continue. We can continue a bit here. I think we talked about the Lambda architecture. We could continue a bit here about Kudu. Apache Kudu. Shwhoop. I want to quickly get into. Is there APIs? Architectural overview, concept and term. Okay, this is. Okay, from the overview. Tables, master, templates. So it's also this is also running on multiple distributed servers, and you have basically master tablet leader, and then you have tablets. So I'm guessing these are shards. Let's say shards, and then you have followers of these. So if one goes down, you have you basically can query from the others. Okay, this okay. It looks a bit like HBase here. Using Impala with Kudu. My guess is that Impala is especially good here for Kudu. Developing applications, schema design, scaling out, security. Let's go to applications. View the API documentation. Okay, this. I would love to see all the sources. Integration with Spark. This is good. Okay. This is harder than I thought. Example applications. Okay, guys. I don't know. I don't want to take your time here and bore you to death. I thought there should be a. What does it say here? What I'm curious about is this direct, basically this direct ingestion here. How is that done? How is the direct ingestion here done? Because I would say this, then you need to post the data from an API or something into Kudu, and like we've seen here in this slide here, direct data ingestion. How does that work? Can we search for it? Search here. Direct data ingestion. Solar. Okay. Transaction semantics. Okay, we cannot go to it. Yeah, guys. If you find any more interesting stuff about Kudu, this direct, basically, how does that work? How can you directly write into this? And if you read from this, how does that work? What APIs or what interfaces are there? I cannot find this here right now. Nick says, I think frankly that in 2019 we have to simplify or even get rid of Lambda. I have to say I'm still a fan of Lambda architecture. You really need to make sure. The thing is, I don't think Kudu is the way for everything here. and I would not say this this general to we need to ditch everything that is working, or we need to ditch that in every case. Yes, there are some cases that would really benefit from it, especially when you look at the problems of the Lambda architecture. That, for instance, in streaming, it's slower until you get the results. Basically, the end-to-end latency is slower. That's a big thing in my from from what I have seen, from my experience. So yeah. um Drink fast. So you use Java with Kudu, or what do you use? Nick says I'm a Python guy. So you use Python to do stuff in Kudu. That's absolutely. Anyway, we have to love and respect Java. Yes, but we're going to leave Andreas with his Java. I have done some stuff in Python, and I think Python is good, but not for what I have done until now. So I could see myself also with Python. This is I always say, if you know one of the languages, of the coding languages, you know them all. The step from, if you know one to from any language to the other, it's not that you can do that, because you know the basic concepts are always the same. Yeah, guys. So I have I went here to a point with the Kudu that I can see the use case here. I think it makes some sense. I don't know the performance, how good the performance is. If you like to do some ETL jobs for analytics or some stuff, I would love to see the APIs here, but I haven't found the APIs, unfortunately. So if you have something, yeah, okay. Again, don't forget to hit the like button. Yeah. Any more thing? Yeah. Nick asks, what do you think about adding Kudu or related thing in the cookbook as alternative to Lambda? Yes, I'm guessing this. The thing with this Kappa architecture, I have to admit, this whole Kappa architecture thing, from the explanations, I'm really having problems with that. With this, it's a bit. How should I say this? It's not that clear as the Lambda architecture stuff. With Kudu, for instance, I can see how this works. This is more practical and not that high level thinking, or high level concepts. I can see this work, and I think this really makes sense, to show people that there is a way to not only do Lambda architecture, to do something like this. Yeah, I think it makes sense. It makes sense. Yeah. Yeah, it's a replacement for HDFS. Yeah, I think it makes. But one more thing, Kudu. Where does Kudu store the data? Where does Kudu store the data? It's a replacement for HDFS, you say, but where does Kudu store the data? Kudu access storage devices. Okay. Okay. Huh, that's cool. Okay, that's interesting. So it doesn't use something like HDFS. It really has its own format with write-ahead logs, and it stores directly on the disk. That's interesting. That's cool. Okay, guys. I think that's it for me for today. How far are we in already? 1 hour 15. Another thing from Dragonfly here. So let me switch to this thing here. So in short, if you don't need to do OLAP type stuff and you want max performance in a highly concurrent OLTP use case, use HBase. I'm not sure. I'm not sure. I'm gonna just check something. So in the facts here, should I use Kudu for OLTP type workloads? How does Kudu relate to Spanner from an OLTP standpoint? Kudu is inspired by Spanner, blah blah blah. Kudu was designed and optimized for OLAP workloads and lacks features such as multi-row transactions and secondary indexing typically needed to support OLTP. As a true column store, Kudu is not as efficient for OLTP as row store would be. Okay. There's also currently some implementation issues that hurt Kudu's performance. Okay. We anticipate future releases will continue to improve performance for these workloads, but Kudu is not designed to be full replacement for OLTP stores for all workloads. Please consider other storage engines such as Apache HBase or a traditional RDBMS. So I think Dragonfly, here's already your answer. There's already your answer in the FAQs. I think. Yeah. That's interesting. Yeah. Nick's 100% right. No need to be sorry. I also think that we should. By the way, if you ask yourself why I also looking here, it's because here's my computer where the comments are, and so I need to, maybe I can switch this around so I don't have to look that far to the left. but I'm reading the comments here down here. Yeah, sorry. No need to be sorry. These kind of technologies really do deserve our attention, and I think we should get more into this stuff. I also said in the future we are also going to look more into single tools. I just didn't have the time here to prepare some stuff for Kudu because I wanted to get the general stream and batch processing down here. Yeah, it would be cool if we find some more use cases of these kinds of Kudu and or documentation like this slide share. Yeah. Okay, guys. That's it for me. It's already about 12 at midnight. Let's say called midnight. Thanks for being here. It was really fun. Again, the comments also every time spot on. Really great comments and lots of discussions. I really love that. Hit the like, share it. Check out my cookbook if you want, and support this channel. And then I'm thinking we are meeting on Wednesday. I'm trying tomorrow to upload all the old or all these episodes onto the podcast. We helped a lot of guys. I hope this one gets more shown to people. Bye bye, and see you on Wednesday. Bye, guys. If I can only find the stop streaming button every time.